Today I'm showing you how to use open source tools such as FreeCAD and Universal G-Code Sender and of course a CNC machine to make a router template to get perfect door hinge mortises every time in just a couple of moments. There's no expensive software needed, just a couple of free programs that you can download from the internet which are open source. But first let me explain why I chose this way. As you can easily see, the mortises that I cut by hand are absolutely horrible. I'm not good at it and I don't really care improving, I just want the job done, and the easiest way to do it if you have a CNC machine is by making a template. Why not make the mortises directly onto the object? Well, it's pretty obvious. It's much easier to fit a small piece of material for a template on the table than a huge door. Besides that, I can also move the template wherever I need it. It's very handy, it's very easy to make. So let's get started. For making the template, I'm going to use FreeCAD 1.0 and a photo of the actual hinge. I'm going to the folder where I have the picture, drag it into FreeCAD. I have measured the hinge. I know it is 30 millimeters long. Double click on the image and here I have a button calibrate. I'm going to zoom into the top of the hinge, click here, then go to the bottom of the hinge, click again, and now let's type here 30 millimeters. You can see the photo has been resized, and now let's make the model for the template. Let's create a new body and a new sketch on the XY plane. The hinge is a little bit rotated, so let's draw a line along this edge. Select the line, go to this constraint, this little arrow here, and select constraint angle. I will just copy this value. I can now close the sketch, I will edit it later. Double click on the image and in the rotation field press Ctrl V. Well, it's actually the other way around, so I will remove the minus. Click on the OK button and now we can double click on the sketch and start again with the tracing. For that I will use the Create Polyline tool. Just make a rectangular shape. And now I need to make the roundovers. For that I'm going to select the fillet tool, click on the first line, the second line, and I have a fillet between these two lines. I will keep on doing this for all the rounded corners. I will start dragging and moving the points around until I get the correct shape. And one more thing before exiting the sketch is marking the point where the door ends. For that I will use the split edge tool. Click here exactly on the edge of the door. Click on the close button and now I can hide the image. Let's create a new sketch which is going to be the shape of the door. Again in the XY plane, and I will create a rectangle. I will use a length of 150 millimeters to be able to clamp the template easy to the door, and the width of 40 millimeters, which is the width of the door itself. Close this sketch and make a pad of 22 millimeters, which is going to be the height of the template that I'm using. Now all I need to do is take this sketch and place it on top of this shape, change its attachment from the XY plane, click on the field, click on the three dots, click on the clear button in the pop-up window and select this top face. When I click the OK button, you can see it has been raised to this face, but I still need to move it to the right and a little bit higher. I will use a value of 80 millimeters for the x-axis. Select the measuring tool, change the mode from auto to distance, select this point and this edge. I will copy this value from here, click on the close button, and now go to the sketch attachment offset position and in the y-axis field paste that value, of course delete the millimeters, and now when clicking away you can see that that point is exactly on the edge of the template, which will sit flush with the door. I will select the sketch, use the pocket button to make a pocket, and I'm using a length of 21.99 millimeters to leave just a 0.01 millimeters skin at the bottom. And that is because I can now select this face and make a pocket operation, but before doing that let's first go to the CAM workbench and set up the toolbit and all the job parameters. In order to create a job in the CAM workbench, select the object that I want to mill and click on this button, which is the job button. In this dialog I'm not going to change anything, just make sure the template is selected, click on the OK button, and the origin is in the correct corner. Now I need to add the toolbit. I'm going to use a 6mm end mill, and now I can click on the add button. Let's find the 6mm end mill. I have to select it and click on the open button, and now I have the toolbit added to the job. The default tool can now be removed. One more thing that I need to set for the toolbit is the horizontal and vertical feed speed and of course the spindle speed. I'm going to use a horizontal speed of 1500 millimeters per minute, the same for vertical, and a spindle of 18,000 RPM. Now let's move to the output tab, and the first field is output file. Here I will set the file name hinges template.gcode. I will use the post processor GRBL. Click on the OK button to close the job dialog. The job is created here. You can see that I need to make a pocket for this hole, which is very simple. Just select the bottom face and click on the pocket shape operation. Let's change the pattern from zigzag to zigzag offset, the angle to 0 degrees. I will use a step over percent of 80%. I will also check the min travel option. Click on the apply button. Here at the corner I will have some material remaining. This edge won't be straight all the way in the template. For that I'm going to go to the extensions tab. After checking the enable extensions, I have one here. Clicking on it will show it on the screen. So I want the cutter head to move a little bit outside of the template. Check this edge here, click on the apply button, and now you can see the cutter head will move all the way to the edge of the object. I still need to go to one more tab, which is the depth tab. First, let's change the final depth from 0.01 to 0. And I will also change the step down from 6 millimeters to 3 millimeters. And as you can see, I have many more layers. I can now close the operation. Click on this button, which is the new cam simulator. Press on the play button. As you can see, everything is milled perfectly as I want, so I can close the simulator, select the job, click on the post-process button, maybe take a look at the G-code to make sure everything is okay. Click on the OK button, click on the Save button, and open Universal G-code Sender, go to the machine, fit the stock to the table and make the milling. So now let's fit this piece of scrap. I've squared it on the planer. And now I want to fit it to the CNC table. I'm going to use the easiest method, which is some screws. One more thing that I need to do, because I've mistakenly created the cutout in this direction, which means it will also cut this guide. I can simply remove these 3 screws and move this piece out of the way. And now let me set the coordinates, the X, Y, and Z for the current positioning of the stock. In order to do that, I'm going to use the probe, but before placing the probe, I have to bring the tool bit as close as possible to the corner to match the dimensions that I have set in the probe module in Universal G-code Sender. You can see all the coordinates have changed according to the probe. One thing that I don't like is the fact that the Z is set to 0 on the top of the material. As you remember, in FreeCAD I've set it at the bottom, but I know the stock is 22 millimeters thick, so I can simply add it to the current Z value, 29.969 millimeters. So let's open the file and press the play button. There is still one more thing that I need to do before removing the stock from the table, which is take this hinge and double check that it fits into the slot. As you can see, there's one little problem here. I need to cut an extra half a millimeter on this direction. On the other direction everything is fine. So let's go to FreeCAD, make the modifications and make the milling again. So let's select this portion of the sketch, select the move tool, select one of the points, move it to the right with 0.5 millimeters and an angle of 0 degrees, of course. Let's connect these 2 points. I've already done it at the top. Now I can close the sketch, go to the CAM workbench, export the file again and overwrite it. Now Universal G-code Sender should update it automatically and I can press play again Of course, there's a lot of airtime by repeating the pocket operation. If I wanted to do it faster, I could have used the profile operation. In the download that you can download on my Patreon page, if you subscribe, you will find the FreeCAD file including the profile operation. But I wanted to keep things simple, so I reused the pocket operation for the video of today. Let's see if it fits correctly. Exactly as it should, a tight fit but without any space around it. So let's remove the template from the table and make a real life test using a piece of scrap material and a handheld router to see how it turns out. Everything turned out just great. The today's template is ready. I can use it on the doors to install this type of hinges. Of course, if I have a different type of hinges, I will have to make another template, but as you've seen in this video, it's very easy, it's very fast, and most important, it costs me nothing. Thank you for watching and see you next time for the next project.